You all doing well? You liking what you're learning? Show of hands, you like what you're learning? And you don't like what you're learning? Show of hands. And you don't feel like showing a hand, you're up way too late and you're just tired. You're moving to the back, what's up?
You need an outlet?
Oh, I need an outlet sometimes too. Do you do drinking or like punching bags or what? Or just go exercise? Oh, electrical outlet. All right, cool. So we're going to talk about HTTP. Last week we were kind of looking at TCP. And we did like a TCP server and we were doing like telnetting in, or we even created a client, did that through TCP. So now we're going to look at doing HTTP. And then we'll see HTTP servers. And then we'll see routing and RESTful and what it means to be RESTful. And then we'll look at serving files, and then we'll review all that, and then we'll look at templates. That's not all going to happen today. So that's going to happen over the next period of time. And, maybe this week we'll get through it all. So just a little bit of foundation of HTTP and how HTTP and all that stuff works. Obviously, HTTP stands for Hypertext Transfer Protocol. We all know that, Hypertext Markup Language. And it's a protocol on top of TCP, and you can look at the spec right here. So I'm not even going to open it because it's like, well, I got to open it now.
Super technical.
It's super technical, dude. Look, it's kind of ironic too, right? Like here's the spec for HTTP, and it's just like plain text. There's absolutely no formatting. There's no markup whatsoever. No, only me finds that amusing. All right. So I know this is like stupid simple, but it's where we start. So remember, it's just this simple because we're going to look at stuff and you'll be like lost in the weeds a little bit and just come back to this, right? Like, hey, servers receive requests and they send back responses. And so here's a picture of what that looks like. So we have, let me make this bigger for you. We have, a browser or a client that makes a request to a server, and there's the HTTP request, and the request has a request line, which we're going to look at, and it also has HTTP headers. And you could also have body down here. Like if we're posting something, right, there could be data. And then we have a response status line, HTTP headers, and content. Hey, welcome. Glad you guys made it. What? No donuts? Don't you want an A? No, I don't eat donuts, so you have to know that that's a joke. All right, so that's what it looks like. And there are these things called HTTP verbs or methods. How many people have heard of these? Yeah, okay, how many people have not? All right, cool. So get, post, put, delete, head. What's get do? I know this is almost like rhetorical. Please humor me. What's get do?
It retrieves a page.
It gets stuff.
Yeah.
It retrieves a page, right? So that would be like, we want to get something because we'll be able to set this stuff. Then we're going to say, hey, we're going to get that. And what's delete do? That's the next simple one, obviously. Deletes. What's head do? How many people know? Yeah, me either. So I looked it up, right? And here's the protocol. The head method is identical to get, except for the server must not return a message body in the response. The meta information contained in the HTTP headers in response to a head request should be identical to the information sent in response to a GET request. This method can be used for obtaining meta information about the entity implied by the request without transferring the entity body itself. The method is often used for testing hypertext links for validity, accessibility, and recent modification. The response to a head request may be cacheable in the sense that the information contained in the response may be used to update previously cached entity from that resource. If the new field values indicate that the cached entity differs from the current entity, as would be indicated by change in content length, MD5 etag last modified, then the cache must treat the cache entry as stale. So that's interesting. So head is used with like checking to see is like, hey, this resource old or is it new, or can I serve the one that's already on the client's computer, or do I have to serve it again? And so etag is something that we'll see a little bit. But anyhow, just put it in your awareness. That's what head does.
I would also guess that it's also used for video. There are some tags you can put in a video HTML tag that make it so that it just kind of reads like the video length and doesn't actually start caching the video itself. I'm not entirely sure, but I would guess that that the head tag would be used to grab like the video length ahead of time and such without having to grab the entire video.
I love it. Cool. And then there's thank you, Daniel. I value your contributions. I do. then we have put and post, and put and post are kind of easy to sort of like what. But if you just sort of think about it from these, that's like the first starting place, right? Like put, I'm going to put something. I'm going to put something up on the server. Post, I'm going to post something. Well, even when you start to describe it like that, it's like, well, that sounds like you just said the same thing. So what's the difference? And if you look for the difference between put and post, you'll see a lot of like information out there, and some of it doesn't really make sense. This is the best piece of information that I found about it. It's at the REST cookbook right here. So post and put aren't the HTTP equivalent of the CRUD's create and update. They both serve a different purpose. It's quite possible, valid, and even preferred in some occasions to use post to create a resource or use put to update resources. Use put when you can update a resource completely through a specific resource. Use put when you can update a resource completely through a specific resource. For instance, if you know that an article resides at HTTP example ... you can put a new resource representation of this article directly through a put on this URL. So if there's already an article there, I could use put to put a new article at that same location, right? If you do not know the actual location, for instance, when you add a new article but do not have any idea where to store it, you can post it to a URL and let the server decide the actual URL. So put when you have the actual URL, post when you don't know the URL. So here's put article 1234, we know it, and we're putting an article. Here we don't know, we're just going to articles, so we're posting. We don't know the exact one, and we're going to let it create it, and it creates at this location right there. So, you know, the main thing isn't to like completely figure out the difference between the two, but when you need to use it, look it up and then figure it out at that time. Do you have any other way of describing that you want to add?
Not really.
Okay. Yeah. So here's the spec on that, and I highlighted the parts that sort of stood out to me, and I'll also let you read that on your own time because that's really small and it's long. So the next thing to look at is HTTP headers. So again, where's that little diagram, right? So we have both the request line and status line, and then we have HTTP headers in both the request and the response. And so when we look at HTTP headers, right, request and response will both have headers. And so you can read more on Wikipedia and read more here too, but here are some of the headers: accept, connection, content type, location, range, refer, transfer encoding, www, authenticate. So we'll look at these in more detail here in a second. But first, does this code look familiar? What's it do? Yeah, it's pretty much like last week, right? What we were looking at last week. And so here we have our main function, and we're doing net listen, TCP 9000. And then that gives us a listener, which here in this code's called a server, and we're going to defer close. I liked it better when it was an LN, but whatever. I named it different when I wrote it this time. So here, and then we close, defer the close of the server, and then we accept it. And when we accept it, that gives us a connection, which is both a reader and a writer. So we pass that into this function we wrote called handleCon, and we defer the close of our connection, and then we scan that connection, get a scanner, and then we go through it, right? And we go through line by line, and we print out whatever text is coming in, and we're printing that out just to what format print line would be going to our terminal. So that's what that does, and we looked at that last week, and that's just basically the TCP thing, and we used Telnet to sort of go into it. And but we could also run this from a browser, right? So we can speak HTTP in our TCP server. So if at a browser we just put in localhost 9000, right? We are going to go to this location. So just that might seem totally obvious to you, and you might have even played around with that. But last week what we were doing is we were just going through TCP through Telnet, and now we could nothing changed. But hey, by the way, take a look. You can also do it this way. You could just launch a browser and go straight to this resource, and this is going to handle all of that. Right? And so when I do that, well, I don't have it here, but let's take a look at it. Beep, 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 beep. Beep, 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 beep. All right, so same thing. Just checking to make sure I'm looking at the right file. And 4201. Go run main. All right, so last week we were just doing like, how do we do the telnet deal? What do you type in? Telnet localhost 9000. Right, and connected to localhost, and then hello. I don't know, is that doing anything? And then it printed it out down there, right? So I did it that way. Okay. I could also do right here. Let me just launch a new tab, and curl -v for verbose localhost. I don't know if I do it like that or colon 9000. And where did my curl go? Host name was not found. Let's try again. Try 9000. Rebuilt to localhost colon 9000. Host name was not found. DNS cache. Connected to localhost port 9000. I'm not sure what I'm typing in wrong, but it looks like I'm doing something wrong. But anyhow, it gave me back some information. Let's see what else. If I do sudo curl -i localhost. Anybody has any corrections to my syntax, let me know. I'm sure I just gave away valuable information right there. Nothing. Sometimes that works for me and sometimes it doesn't. Nothing. All right. But anyhow, so now we could go to our browser and we could just go to localhost 9000 and right? But if we come over here, do we see anything over on WebStorm down here? And maybe that's where, let me Command K that. You have something you want to add in there?
No.
No. Refresh, come back over here. And so we got some information here. Connection, keep alive, accept, upgrade, user agent, accept encoding. And so we have, right, what we were looking at with our headers. By accept, upgrade user agent, accept encoding, accept language, accept. I don't know. So different headers came through. And you can also see those in your browser, localhost 9000, and then go into developer tools. And so developer tools, you can come into this little icon in Chrome right here. And I never go here this way, so I got to think about this actually for a second. More tools and developer tools. Or you could do Command Option I.
I think it's F12 too on most things.
Command Option I or F12. And so now when I do this, I'm on the network tab right there, hit refresh, and it gave me a whole bunch of stuff. Holy cow, what? I'm at Google. I'm like, what the heck? Let me clear all that. Wait, I'm back at Google. Clear all that. So anyhow, in here somewhere.
You're not actually getting a response from the...
Yeah, I'm not getting a response, that's why. All right. So, headers. We could access this through our browser. That's the main point. So here are request headers. So if I do that localhost 9000 like we just saw, we get this information right here. And so just to look at that, we have right here our verb. It's a GET request. We're saying, hey, give me this resource. And then we have the URL we're asking for, and so that's just a /, right? And then we have the HTTP protocol version, HTTP 1.1. And then we have our headers right here. And so, that's, again, this first part here is the request line. So here's the request line right there. And then this next part here are the HTTP headers. And so here are the HTTP headers. And headers have key value sort of association. And so here's the sort of syntax for how that works. You have your headers, your request line, and then you have your header and then message body and carriage return line feed right here. And request line has your method, the request URI, and the HTTP version, and then carriage return line feed. And so that's what we saw right here. Right? We have the method, we have the request URI right there, or URL, whatever you want to call it, and we have the HTTP version right there. So here the URI, right, is The host is here, localhost 9000, and then here's the, whatever you're looking for on that server. All right, so here I've got everything after this 9000, the / and all of that. I notice it doesn't really translate to much yet. So that was so we use get if there's no message body. This is on the request. And we use post if there is a message body. So like with a form, we want to send over some stuff from form, we use post on forms. So response header, so status line, and then the header, and then the message body. And you can see status line again is HTTP version, status code, and reason phrase. So that's kind of different. And so here we have, see, sudo curl IW, that one worked. So here we have HTTP version, status code, and reason phrase. HTTP version, status code, reason phrase. So that's your, what's that part called right there? Status line, right? Request line, status line, there we go, status line. And then we have the headers beneath that. Oh, there it is. I had it right there. And so just sort of showing the difference between sudo curl -I Google and sudo curl -I www Google. www Google gave me status 200, all's okay. And just google.com gave me a redirect, 301, move permanently, and then sent me to a new location. And so here you can see a header in action, location. So when I do a redirect, it takes location, sends me to this new location. All right, so back to the basics. To make an HTTP server, we need to parse the request and then serve the response. So we saw how to do a TCP server, and we saw how to go into that with Telnet, and then we also saw how we can access that right through HTTP, and we're able to talk with it. And so to make an HTTP server, we just need to parse the request and then serve the response. And so we're just going to kind of build this up and see how we would manually build an HTTP server. And then we're going to see how there's an easier way to do it, like a lot of the technical intricacies are already written for us in a package that comes in the standard library. And so what we're looking at now is just like, if that wasn't all written for us already, then how does that actually work, beneath the surface? What's going on there? So we're going to look at a simplified version of that. So first we looked at like TCP, and how do we stand up TCP just from nothing? Using the standard library, right? That's like the most basic. And then we connected to that with Telnet and TCP. And then we saw, we could connect to that with HTTP. And so now that we have that basic framework, how do we build an HTTP server? Well, we're going to have to listen for requests. And when those requests come in, we have to parse them and do something. And so part of what we'll do is we'll look at the verbs, like what verb is coming in. And based upon the verb that's coming in, do one thing or another thing. So we'll have some conditional logic. And then, and depending upon what we do, we'll then serve back a different response, right? So HTTP server from scratch. Ba-dum! So again, we have net listen, gives us back a listener, which I've called server. Sorry for the switch in syntax there, but I was calling that ln last week. And then we have we accept that, which gives us connection, which is reader and writer. And then we have handle connection, right, which we pass in our connection, and we defer. And then we have a scanner, so we create a scanner and bring in that to a buffer, and then we start scanning, and we get the line of text, and then we can print that line. And if I is equal to 0, if I is equal to 0, method is strings.fields ln 0. What? Format println method else nothing I++. What's that doing?
ln is your scanner text, and so it's saying there's nothing in that line of text.
Okay. Good start. Absolutely right. That's my line of text. And there might be nothing in there. But what is this syntax right here? Okay, what's strings.fields do? That's the first thing to understand. Strings.fields is going to break a string of text up into its words, right? So if I got a bunch of words, it's just going to break it up into words. And so my first, I scan this, and my first line is I is 0, right? So the first time I scan this, my first line is this line right here, get HTTP 1, right? So I have my verb, and then I have my URL, and then I have my HTTP, what's that called? Protocol, HTTP protocol. What was the exact word on that? Sorry, I'm a stickler for exact words. Oh, there it is. Protocol version. There we go. So so here I scan. I get this will bring me my first line. So if this is my first time through, I get this line. I break that up into words, and I say give me the very first word, and that should give me the method. So that's assigned to method right there. And so print line method, here's my method get. So good, I just said we're gonna look at our HTTP verbs, and based upon different verbs, if one or another's coming in, we're gonna do something, or if another one, we're gonna do something else. So the first thing we need to do is we need to get access to what is the verb coming in. So we just got access to it. And then we add this chunk of code right here. So here is where we're getting access to the method, right? And then down here, body, right? We're just setting it equal to that text, and we're going to IO write string, and that takes a writer, so we're going to write back to our connection, and we're going to put in this line right there, HTTP1 200. What's that look like? Status line of response, right? And what's this first part? So that's your HTTP protocol version, and then what's this part? Status code, and then a status phrase, right? And then we need R and an N. Why an R and an N? Why not just an N? Carriage return line feed, right? So the R is the carriage return, N is the line feed. Oh my gosh, this is a little bit brutal, right?
It requires the Windows line endings.
Yeah, and then so we write that line, and then format fprintf connection. Why'd I go from IO write string to fprintf? What? The reason I switched here is because IO write string takes a writer, and fprintf takes a writer, and you could use either one. And fprintf is file print with formatting, and so here I've added in just the way that one works. So I just put these two ones in here to sort of illustrate how using interfaces, right? Since each of these takes a writer as its first argument, then you could use either one and just pass in either one. And this is going to do content length, %d, so that'll give me the length of the body, and I'll put it there and give me a carriage return on the line feed. Content length. So what is this right here? What is content length, colon, and then some value? What is that? When we talk about HTTP, this is a what? What part of this image does that belong in? Does it belong status line, header, or content? It's a header, right? All right, so there's the header, right? We pass in the header. And then we do a carriage return line feed, and then we do the body. Where's body? Oh, body's right here. Body's hello world 2. So here's the body of our response, right? We had a request come in, and that had a request line and then some headers. And we took this and we said, what is that? And we got get off of it, right? And then we're going to write a response, and we have to give it the status line, the headers, and the content. Hold on. I told you we were going to go into the weeds, and when we go into the weeds, to remember this. Right? But it is really just that simple. I mean, it's just this diagram right here. And all we're doing is we're taking this diagram and saying, how do we translate that to code? Laura, you got a question?
That content link, is that going to be the size of your body that's reported in the headers? Okay.
Yes, yeah, it says length body.
Okay.
Yeah. And I don't know what happens if, HTML browsers are pretty forgiving, so I don't know what happens if you don't include that. It'll probably just read it just fine.
Probably the 4 major browsers will. If you run some obscure browser or whatever, it may complain.
But it's good practice just to say, hey, this is how much stuff I'm sending you. Right? So we didn't really do anything. Whoa. We didn't really do anything. We didn't switch on, because we get our method get here, right? So, right, if I curl this, curl localhost 9000 hello world 2 is what I get, and then it gives me back these headers. And so we don't do anything with this method get yet, but we are seeing how do we actually write back a response. And so, the response here that gets written back is, let's see, where does this translate to? HTTP 1 200 OK. I wonder if I have a picture of that. No, this is just showing how I get it here in curl versus here in the browser. All right, that's just the get method. All right. So connection is a reader-writer, so that's just showing you that bit, difference between write string and fprintf. So you can keep building from scratch. So here we have, this gets that part, the get, right? We already saw that. And then we have string fields length 1 URL gives us this right there. So 0 gives us that, 1 gives us that. We can then start doing request routing based on the URL, right? Because we got, our verb, and then we also got our URL right here at the server. So we could start doing request routing. The main point here is to make an HTTP server, parse the request, and then serve the response. So here's an exercise which you can do at home. Create a TCP server which can handle a simple HTTP request and return the URL that was passed into it. How many people think you can figure that out from what you've been given? Raise your hand. How many people know? Okay, cool. HTTP headers. What more do I have to say about that? We're going to explore some of the different headers and what they say, just, or what their settings are. So content type, application, form, URL encode, multi-part form data, text plain. So content type, I could send over just text plain, or I could send over, I left one out. What's the one for not text plain?
Text HTML.
Text HTML. Yeah, I'm pretty sure. Let's look. Content type. I don't know why it doesn't work on some networks. Let's try this with sudo. So, hello, content type. Text HTML, content type. Carset ISO 88591.
They're not using UTF-8.
Interesting. So multi-part form data versus application that. What are the differences between those? I've actually kind of forgot since I wrote this. Form content type, we have multi-part form data, application, has something to do with posting. This is the default content type. Form submitted with this content type must be encoded as follows. And the multi-part form data, files, non-ASCII data, and binary data. So this is for files, non-ASCII data, and binary data. So if you need somebody to upload a file, you need to do that. And this is just for, is that right? Just for forms? I guess that's right.
It's supposed to be the multi-part form data is multi-part. It can be run into multiple different packages if needed in case you're sending something really big.
So that would get sent on the request or on the response? It's on when you're uploading something. Somebody's uploading it.
Whatever your content is. So if they're uploading, or if the server's sending back a big file to you too.
A little bit more about verbs post here. Oh, here we go. I got more of a description. Multi-part form data is an encoding type that allows files to be sent through a post. So when you're submitting, so a post. There we go. Quite simply, without this encoding, the files cannot be sent through post. If you want to allow a user to upload a file via form, you must use this enc type. So set that when you're uploading files. Like I said, painful, right? Like a lot of intricacies, a lot of details. Oh, and so here I even demonstrate it. Sorry, I didn't get a chance to look through my notes before I came to class. That's why I'm fumbling just a little bit. I'm like, what am I trying to say? It goes better when I look through before I come to class. All right, so here I have let's see, func handle connection, and maybe I have more code down there, but here is a form, and I could submit that form, and it's post and text and key, and so it's basically this right here. And then when I submit, right, I get a post. So the first thing, let's see here, I go to go run main.go, and then it looks like
Type it in a web browser. Or something.
type it in as a web browser, and I get this, right? And then, whoops, I want to scroll, but it doesn't scroll. And then again here, my fave icon. That's kind of nuts, right?
Yeah, web browsers will look for the favicon.ico by default if it's not specified otherwise in the HTML to be the icon that it puts on the tab with the page.
Yeah, and then when I post, I'm posting that one www form URL encoded. So that's my content type, right? So if this was that one is just for a normal post. If it was going to be like upload a file, I would need to use multi-part form data to upload a file. Phew. Intricate, right? A lot of intricacies. So here, localhost 9000, and there's that URL. So when I load this page, I get that file, and I got it, and then gave me the content length and the status code and request headers and accept encoding, right? And so just showing you some of the headers there. I thought maybe we were going to add something. And then here's when I post. So that's just another way to see it. Whoops, I switched pages. And you can see the form data right here. So here I pass in test, and I can see that form data. And I could also click, to view source, and it shows me what it looks like before it's been parsed by the browser. So here I set the content type to text plain. And so when the browser gets it, instead of it being text HTML, it says, oh, that's just plain text. Okay, there you go. And it prints it out like that. So it doesn't interpret it as HTML. So back to the headers, we have we looked at content type. Now we have connection. And so connection keep alive and closed. Keep alive needs a content length, otherwise doesn't know when request ends. And HTTP persistent connection, also called HTTP keep alive or HTTP connection reuse, is the idea of using a single TCP connection to send and receive multiple HTTP request responses as opposed to opening a new connection for every single request response pair. The new HTTP 2 protocol uses the same idea and takes it further to allow multiple concurrent request responses to be multiplexed over a single connection. Right? But there's connection. So I don't know, what was connection? Do we see connection anywhere in here? We have, oh, whoa, sorry. We have connection keep alive. Where is it? Right there. Connection keep alive. And then we have location, and that's used for redirects. We already saw that. So you go to google.com, and it redirects you with the 301 status code to www.google.com. Oh, there it is. And then we have, here's the status code, 302. What did they do? 301 move permanently. 302 redirect. And you can see all the status codes right here. So like 302 found, 301 moved permanently, 400 bad request, 404 not found, 200 okay. right? If I ever make a lot of money in life, I want to get a nice car and have my license plate be HP 200. Everything's okay. Someday, man.
Somebody doesn't already have it.
Yeah, somebody probably already has it. It's pretty cool. And then we have another header range for resuming downloaded file. So you get partway through download, you break a connection, you know, range will somehow let you resume where you left off. Not totally sure how that works. And then we have refer, and that's misspelled in the spec, so you have to use it that way. I think that's funny. And you use it to see where a client came from, but it's not trustworthy because you can spoof it easily, right? And then we have authenticate, which is basic access authentication. It's not secure, you shouldn't use it, right? And so there's an example of how that's not secure. If you go look up the Wikipedia article, right, you basically take, it encodes it as base 64, which is, you know, easy to translate. And so, you know, you could just unencode it very easily. If it's HTTPS, then it would be more secure. But and finally, we have a caching. And with caching, there's much to know. And I put together this resource right here. And this is basically about the critical rendering path. And here it talks about caching. And here you can learn about e-tags. And so there's a little flow map here, which you can look at somewhere. Here we go. Like where you could determine how do you set your cache policy, right? So I know that was a lot, and that's like kind of overwhelming, and I don't even fully understand it, which is why I explain it in herky-jerky fashion. But you know, that's the difficulty of standing up an HTTP server just like on your own without using anything that's already pre-written for you. And it's just this entire process of, you know, like, okay, let me get the stuff that's coming in. Dang it, I'm like jerking all over the place today. Get the stuff that's coming in, and then, you know, get my HTTP verb and figure out what the method is, and, you know, what's the URL path, and then let me translate that into doing something, and then write a response. All right, so that's the difficulty of creating an HTTP server from scratch. So in the next video, we're going to look at using the standard library to do that, I hope. Yeah, as we saw previously, parsing HTML manually is brutal. PackageNet HTTP is here to make life easier, so we'll take a look at that next.